Hello watchers, this is Calcuwin and never be loose using calculus. I am Rachelle Angelica M. Deniega and I am here to teach you the limits. But before we proceed in discussing the limits, I will show you an example of evaluating a function. 2x minus 5 with the value of x min equals to 2. Substitute 2 minus 5, which result to 4 minus 5 equals to 1. So that's the answer. But in the second example, we can see that the value of x is 10. When we substitute the value of x, this is what happens. We result to 0, which is give us an undefined solution. So in this video, I am going to discuss the limits using the table of values. So in solving the limits, we are going to use the notation. What does this notation mean? Lim stands for the limits, f of x stands for the function, which also means f of x is equals to y. X approaches c, and lastly, the letter capital L, which means limits. But how do we read this? The limit of the f of x as x approaches c is equals to the limits. So to further understand the limits, I am going to discuss and introduce you to the 4 cases and examples. So in the first example, we are going to solve for f of x equals to lim 3x plus 1 as x approaches 2. I want you to focus on 2 things. First, 3x plus 2. Second, x approaches 2. So in finding the value of 2 on x tables, we are going to find a number in left hand side that is closer to 2. As well as on the right hand side. And now, we are going to substitute the value of x to the function in order to get the y values. We have now the value of one-sided limit, which is 7. Compare the left-hand side and the right-hand side of one-sided limit if they are the same. If the value of one-sided limits are the same, then the value of two-sided limits does exist, which is the f of x equals to lim 3x plus 1 as x approaches 2 is equals to 7. In this example, You can notice that when you direct substitute the x, it will get a zero or undefined solution. So you need to factor out the polynomial. 2 and 3 are the factors of 6. Then cancel all the like terms, which results to f of x is equals to lim x plus 2 as x approaches 3. Then again, I want you to focus on two things, x plus 2 and x approaches 3. Then again, find a value that is closer to the 3 on the left hand side, as well as on the right hand side. Then let's do the direct substitution of x values to find the values of y tables. As you can see, we got 6 on the left hand side, while on the right hand side, we got 5. Which also means that one-sided limits are different, thus the two-sided limits does not exist. So always remember, when your one-sided limits are not the same, then the two-sided limits does not exist. In this function, let's try to solve this function of f of x wherein the function is the piecewise function. I want you to take note of the three things. First, f of x is equals to x plus 1 if x is less than 4. Second, open and close parenthesis x minus 4 squared plus 3 if x is greater and less than 4. Third, as x approaches 4. So in order to get a number for the left hand side, we will get any number that is less than 4. And as well as for the right hand side, we will get a number that is greater and less than 4. So in order to get the y values of left hand side and the right hand side, we will do a direct substitution first to the left hand side, which is the function x plus 1 if x is less than 4. As well as for the right hand side, which is open and close parenthesis x minus 4 squared plus 3 if x is greater and less than 4. So as we can see in our one-sided limit, we got a different numbers, which means our limit does not exist. For our last example, we will evaluate and solve for the infinite limits. Again, let's take note for the following. First, x minus 4 over x minus 5. Second, x approaches 5. The process is still the same. We will direct substitute the value of x to the function in order to get the left-hand side limit and the right-hand side limit. So upon solving the left-hand side and the right-hand side, we can notice that the table of values is increasing instead of approaching 5. So in conclusion, f of x is equals to lim x minus 4 over x minus 5 as x approaches 5 is also equal to does not exist, or in this case infinity. So then again, always remember, in any cases, when your one-sided limit are not the same, then your two-sided limit does not exist.
Welcome back to Calcuwin. Never be loose using calculus. After limits, we're going to derivatives. Let's start from definition of derivatives. What is definition of derivatives? So here is the definition of derivatives. Derivative of a function of a real variable measures the sensitivity to change of the function value or the output value with respect to the change in its argument or the input value. Next, derivatives are fundamental tools of calculus. For example, the derivative of the position of a moving object with respect to the time in the object velocity. This measures how quickly the position of the object changes when time advances. Do you want to know the formula for the definition of derivative? Yes, m is equals to change of y all over change of x, and deriving a dy all over dx is equal to the limit of f times the quantity of x plus h minus f times the quantity of x all over h, wherein h approaches 0. Using this formula of derivatives, we can find the derivative of an equation. Now we have the definition of derivatives formula. Let us now discuss the steps in finding the derivative. Step 1. Substitute the value of x to the equation. Step 2. Evaluate the function with n plus h and n, wherein n is the any value. Number 3. Distribute the constant and perform necessary operation. Number 4. Add all the constant terms. Number 5. Cancel the common factor. And number 6. Solve for the limit. That's it. We have now our first example. F of x is equals to x plus 9. So that's the equation. And let's solve for the f prime, which is the 2. So let us start from the equation. We have the formula, which is f of x is equals to the limit of f times the quantity of x plus h minus f times the quantity of x all over h, wherein h approaches 0. So let us substitute the value of 2 to the x. So in canceling all the common factors, we're gonna derive at h over h. So applying what we have learned on the limits, h approaches 0, we will arrive a limit of 1. So our final answer is f prime of 2 is equals to 1. Now we have the second example, which is the equation is f of x is equals to 7x plus 5. Solve for the f prime of 5. Now let us start solving. We should put the formula first and substitute the value of x, which is 5, on the f prime of 5, and we should cancel all the common factors. After simplifying and canceling all the common factors, we'll derive a 7h over h, wherein h approaches 0. Applying the limit of h approaches 0, wherein f prime of 5 is equal to the limit of 7, h approaches to 0. Or in short, our final answer is f prime of 5 is equals to 7. After discussing our examples, now we should try this. First equation, f is equals to 2x minus 3 raised to 2. Solve for the f prime of x. Second equation, f is equals to 2x minus 3 plus 4x squared. Solve for the f prime of 1. And last question is f is equals to 3x plus 9 minus 11x squared. Solve for the f prime of negative 1. Let us grab our papers and pens, and we should start our solving time. So let us substitute the values that we have derived early on. 4x squared plus 4h squared plus 8xh minus 12x minus 12h plus 9 minus the quantity of 4x squared minus 12x plus 9 all over h. So we just simplify this. This negative sign should be distributed to this quantity. So let us simplify. So after distributing the negative sign to this quantity, we have arrived to this answer, and we should simplify this one. So after simplifying, we have derived this answer. Let us just simplify this one. Fx plus x squared minus fx squared is equals to 0, or this could be cancelled, plus fh squared, we can put this one since there are no h squared, plus 8x 8xh. Then negative 12 should be cancelled by the positive 12x. Negative 12h, there's nothing to cancel, so we should put this one 2. And plus 9 minus 9 can be cancelled all over h. So we have derived this answer, fh squared plus 8xh minus 12h all over h. Since, have you noticed in this numerator that they have the same variable, which is the h. So we can bring out h, and this will be the answer. H times the quantity of fh plus 8x minus 12 all over h. Now we can, since h is out, we can cancel the denominator h and the numerator h. We have for h plus 8x minus 12. Wait, minus 12. So we will just find the limit of 4h plus 8x minus 12, where h approaches to 0. So we have derived by 4 times the quantity of 0, which is this is the h, 0 plus 8x plus 12. So we should just simplify this, and we will get the answer. So we just simplify this. Sorry for my handwriting. 4 times 0 is 0, plus 8x plus 12 is equals to the 8x plus 12. So this is our f prime of x. This is the final answer. For our second equation, 2x minus 3 plus 4x squared, we're in solve for the f prime of 1. So f prime of 1, substitute the 1 to the x values. Simplify this. 2 times 1 is 2, minus 3, plus 4 times the quantity of 1 square. 1 square is 1, so 4 times 1 is 4. Simplify this. This should be negative 1 plus 4 is positive 3. This is the answer for f prime of 1. Now let's solve for the f prime of 1 plus h. Substitute the value of to the x is 1 plus h minus 3 plus 4 times the quantity 4 times the quantity of 1 plus h squared. So distribute the 2 to this equation. 2 times 1 is 2 plus 2. 2 times h is 2h minus 3 plus, first get the value of this, which is 4 times the quantity of h squared plus 2h plus 1. Simplify. 2 plus 2h minus 3 plus 4. Distribute the 4 to this equation. 4h squared plus 8h plus 4. Now let's just simplify this equation. For h squared, next is this 2, positive 10h, cancel. Now let us simplify 2 minus 3 plus 4, which is 3, positive 3. So this is the answer for the f prime of 1 plus h, and this is the answer for the f prime of 1. So remember these values. Now let us use the formula. F prime of 1, yeah. F prime of 1. So substitute the values that we have derived early on. Fh squared plus 10h plus 3 minus 3 all over h. So we can cancel this too. Fh squared plus 10h all over h. So they have the same terms, which is the h. H. Let us bring out h. 4h plus 10 all over h. So we can cancel this to h and h. We have the answer for h plus 10. Now let us get the limit of this equation. The limit of 4h plus 10 where h approaches to 0. So 0 plus 10 equals to 0 plus 10 is 10. So this 10 is the answer for f prime of 1. This is the answer. So for the last question, f is equals to 3x plus 9 minus 11x squared. Solve for the f prime of negative 1. F prime negative 1 is equals to 3 times the quantity of negative 1 plus 9 minus 11 times the quantity of minus 1 square. So simplify this equation, we will arrive for negative 5. For the next is f prime of negative 1 plus h. So substitute the value to the equation, this one, and simplify, we'll arrive 11h squared plus 23h minus 5. So this is the answer for f prime of negative 1 plus h. So put the values to the formula, this one. So negative 11h squared plus 23h minus 5 plus 5, this can be cancelled out, and this 2 has the same term, which is h. So h will bring out negative 11h plus 23. H and h can be cancelled out since these two are not in the same position. This one is in the numerator and this one is on the denominator. So we will have 11h plus 23. So let us get the limit of negative 11h plus 23 where h approaches to 0. And negative 11 times 0 plus 23. We will derive an answer for f prime of negative 1 is equals to 23. Thank you for listening to my discussion. I hope you have learned something. I am John Christian A. Lantin from Calcuwin. Calcuwin, never be loose using calculus. Up next is basic rules of derivatives. Get it on!
Hi, I am Patrick Minlay and I will be discussing the basic rules of derivatives. The first rule is the constant rule. This rule states that the derivative of any constant is equals to 0. For example, the derivative of 40 is equals to 0. The derivative of 500 is equals to 0. The derivative of 230 is equals to 0. And the derivative of 5 is equals to 0. The second rule is the identity rule. This rule states that the derivative of any identity function is equals to 1. An identity function is a function that always returns to the same value that was used as its argument. For example, the derivative of x is equals to 1. The derivative of r is equals to 1. And the derivative of y is equals to 1. The third rule is the constant multiple. The derivative of a function that has a factors of c is equals to the derivative of the function multiplied by c, where c is a real number. For example, the derivative of 38x, using the identity rule, x will be equals to 1, so 38 multiplied by 1 will be 38. Another example is the derivative of 680. 680 multiplied by 1 will be 680. The last example, negative 450 multiplied by 1 is equals to negative 450. The next rule is the power rule. This rule states that the derivative of a variable raised to n is equals to n times the variable raised to n minus 1. For example, the derivative of x raised to 5 will be n, which is 5, times the variable raised to n, which is 5 minus 1. And the answer will be 5x raised to 4. Another example is 40x cubed. To get the derivative of this, we need to multiply 40 and the derivative of x cubed, which is 3x squared. And the answer will be 120x squared. The last example is 15x squared. To get the derivative of this, we need to multiply 15 times the derivative of x squared, which is 2x. And the answer will be 30x. The last rule is the addition and subtraction rule. This rule states that the derivative of a multiple function or terms being added or subtracted together is equals to the sum or difference of the derivatives of the equation. The first example is 4x cubed plus 2x squared minus 5x plus 44. To get the derivative of this, we need to use the other basic rules. The first term will be using the power rule, which will be 4 times 3x squared. Again, the second term we will use the power rule, which will be 2x times 2. The third term we will be using the identity rule, which will be 5 multiplied by 1. And the last term we will use the constant rule, which will be 0. And the final answer of this will be 12x squared plus 2x minus 5. Another example is 6x raised to 4 minus 10x squared plus 5x plus 60. To get the derivative of this, the first and second term we will use the power rule. The third term we will use the identity rule, and the last term we will use constant rule. And the final answer of this will be 24x cubed minus 20x plus 5. The last example is 540x raised to 4 plus 5x minus 600. The first term we will use the power rule. The second term we will use the identity rule, and the last term we will use constant rule. And the final answer of this will be 2160x cubed plus 5. So that was the 5 basic rules of derivatives. And up next will be the additional rules for derivatives.
So now that we are done discussing the basic rules of the derivatives, let us now discuss the additional rules of the derivatives. So there are some instances that we cannot just use the basic rules of the derivatives. That's why we have the additional rules of the derivatives, which are the product rule, quotient rule, and the chain rule. So the first rule that we are going to discuss is the product rule. So let us now discuss the first rule of the additional rule of the derivatives, which is the product rule. So this is the formula in solving the product rule. Let's have an example in solving for the product rule. So we have here x squared plus 3 times 2x minus 5 So let's assume that this is the f of x and this is the g of x. Now, let's get the f prime of x and g prime of x. To solve for the f prime of x, we have to get the derivative of the f of x. So the derivative of f of x is 2x. Now, to solve for the g prime of x, let us get the derivative of the g of x. So the derivative of the g of x is 2. Then, we have to multiply the f of x to g prime of x.
Then we have to multiply the g of x to f prime of x. So x squared plus 3 times 2 is equal to 2x squared plus 6. And then 2x minus 5 multiplied to 2x is equal to 4x squared minus 10x. So let us combine these numbers. This is equal to 6x squared minus 10x plus 6. So this is the final answer. After that, we are going to discuss the next rule, which is the quotient rule. So this is the formula in solving for the quotient rule. Let's have an example in solving for the quotient rule. So let's assume that this is the f of x and this is the g of x. So again, to get the f prime of x and the g prime of x, we have to get the derivative of f of x and then the g of x. So the derivative of f of x is 10x minus 3. And then the derivative of g of x is 6. Now, let us multiply the g of x to f prime of x. This is 6x plus 7 times 10x minus 3. Then we have to multiply the f of x to g prime of x. This is 5x squared minus 3x plus 4. Then multiply to 6. Over g of x squared. So this is the g of x. 6x plus 7 squared. Let us now multiply the first term, which is 60x squared plus 52x minus 21. So this is the product of the first term. Let us now multiply the second term. This is 30x squared plus 18x minus 24. So this is the product of the second term. Now, compute for the numerator, that is 30x squared plus 70x minus 45 over 6x plus 7 squared. So this is the final answer. So lastly, we will discuss the last rule of the additional rules of the derivatives, which is the chain rule. So this is the formula in solving for the chain rule. Let's have an example in solving for the chain rule. So we have here x squared minus 5x plus 7 raised to the power of 5. So let u be x squared minus 5x plus 7. Now, let's get the derivative of u. So the derivative of u is 2x minus 5. Then let us write this as u raised to the power of 5 times du. So first, let's get the derivative of u raised to the power of 5 times d, which is 5 u raised to the power of 4 du. So let's substitute the value of this. Five times x squared minus 5x plus 7 raised to the power of 4. And then the value of du is 2x minus 5. Then multiply the du to 5, which is 10x minus 25. And then we just have to copy this, which is x squared minus 5x plus 7 raised to the power of 4. So this is the final answer. So let's have another example of chain rule. Let's have dx over x squared minus 3 raised to the power of 4. So let u be x squared minus 3. Then let's get the derivative of u, which is 2x. And then let's write here du over u raised to the power of 4. Then we have to transfer the u raised to the power of 4 to the numerator, so the exponent will be negative. So that's u raised to the power of negative 4 du. Then let's get the derivative of this. That will be negative 4u raised to the power of negative 5 du. Now we have to substitute its value. Negative 4 times x squared minus 3 raised to the power of negative 5 times 2x. Then multiply the negative 4 to the 2x. And then write this to the denominator, so the exponent will be positive. So that's x squared minus 3 raised to the power of 5. So this is the final answer. So that's it for the additional rules of the derivatives.
Hi again, watchers! Again, this is Rachelle Angelica M. Deniega,
I am John Christian A. Lantin.
I'm Patrick Minlay.
I am Corrine Vibal.
and thank you for listening to me. This is
Calcuwin.
Never be loose.
Using
Calculus.
I'll blame it on the better days. I'll even blame it on your pretty face. Cause baby, I can't see no wedding day ahead. It won't be me or kissing in the rain.